Hello everyone. So today we'll see permissions. So why permissions are important? Why do we need to change permission and how to do it? Means why we need to give someone a permission and not other one, and when or how, or why we need to remove a permission from someone and give it to another one. So we see how to change the permission strings of files and directories, which command we are going to use, which is chmod, and we see how to invoke and use the interactive shell. Then the second part, we see how to zip the directories or unzip. Okay, so let's start by the utility of the permission. Why do we need to assign a permission to a user, or why we need to remove a permission to someone or to a group of people? The reason here that we care about permissions is that, as I mentioned previously in the beginning of the semester, that Unix was designed to allow multiple users to share computing resources that were very expensive at that time. So it was originally designed to be multi-user system, and Linux is too. So if you remember when we were installing the virtual machine, I mentioned that you have the username and the machine name. The username can be Amal, Alex, John, whatever. And all these users can be connected to the same machine, Amal, for example. So here we need a way to protect these users from each other and to protect the system itself. How to do this is to have or to give a permission to someone depends on what he needs to access to it. So for example, we have in a directory a group of people, or let's say group one of people that they are working on project one, and group two are working in project two. So we don't need that group one connect to directory of group two, and also we don't need that group two connect to the project of group one. So here we'll give the access or the permission to access to read or to modify to only the, for example, for group one to access to the project one, and for group two to access to project two. So here to protect and also to organize. So everyone, for example, by some typo, group, if you don't organize by permissions, group one or some people from group one can access by mistake to project two and start creating files there, etc., which is not supposed to be. So group one should be working on project one. So we just give them the permission to work on this. Or more better, only see what they need to see. They don't need to see project two, say, so they don't have permission to read it or even see it. So this is why it is important to give or to work with permissions. Now, there is the concept of a super user who has the highest permission level and can access anything on your system. So there is no restriction for the super user, which can be, for example, the manager, the boss, or whatever. So running commands as root privileges, or super user are all the same thing. So if enabled, you can run commands as a root. The root account has the highest permission levels, as we said, so he can do anything. That's why if I am a hacker, I will try to access to the root because I got the root password. If I got the root password, so I can get anything or I can do anything. So here, be careful because this is really risky, let's say, powerful and risky, because okay, you can control anything, but you need to secure this one and not give the power of the root to anybody. Only the one who needs to supervise or everything. So how to become a super user? Actually, there is a few different ways that you can become a super user. For example, if I want to view slash etc shadow by just doing cat and the name of this directory, which is, so shadow is a system configuration system configuration file that is used to store the passwords for all the user accounts. So if I do cat, I wanna see what is inside into the system configuration file. So I will say permission denied. Why? Because being a general user or a normal user doesn't allow me to view this file. I should, or the only one that can see the content of this file is the super user. Now, as a normal user, if I want to try to cat etc shadow, it will say permission denied. So let us go to the virtual machine and see what if we type cat. Now, as you can see here, the username is Amal, so it's not the super user. And we want to see as a general user the content of etc shadow, which is usually giving the configuration system file, the password saved there. So it will say that permission denied. We need to be a super user to connect to this one. So this is the one of the utilities of becoming a super user. For example, if we type the command that we just saw it and we type cat or sudo cat etc shadow, at this time it will ask you for your password, and now it will show you all the user accounts and their encrypted passwords. So only the super user has the power or the ability to see this file. Now, in this class, I'm not going to ask you about what this file means, but I'm just trying to show you one of the reasons why we want to become a super user. The reason is, or the answer is, to be able to view the system configurations files that they are usually protected. This is one of the reasons, of course. So the normal user account does not have permission to view this system file. If I do ls-l etc shadow, it will show root. Now, if you are typing your password and it is not showing up, that is a feature and not a bug. It is intentional so that people cannot see your password. So actually, it's for your own benefit to protect you. So anytime you create a virtual machine with Ubuntu, you will create a user account and that user account is going to be the admin. And as an admin, you can add multiple users using the command sudo user add name. But this is beyond the scope of this class, so there is only one user account and different system accounts here. This is what we will be focusing on this class. Now, if you wanna, we know now why we need to be a super user. Now, let's see how to be a super user, how to execute this type of commands. Now, if you are just going to run a single command as root, you can just type sudo your command, for example, cat test1.txt. Now you are executing this command as a root. Why? Because you are using the sudo. Now, if for example, you are a manager and you have multiple commands that you want to type, you don't need every time to type your password because if you have a single comment as a root, it will ask you to enter your password. And your password here is the one that you used or you created when you are installing your virtual machine. So, for example, in the first example, when you are trying to see the content of test1.txt as a root, it will ask you to enter your password. Now, instead of every time we type a comment, it will ask us to enter the password, we can just put sudo-i. And here to run multiple commands. So it will just ask you once to enter your password, then you will be running the upcoming commands as a root. So we will start your new shell as root where you can enter one command after another. Let's see an example. So here, as you can see, we were trying to execute a command using a general account, not the super user. Now, if you want to type sudo, then let's say cat test1.txt. So here it will ask for a password. And as I mentioned, the password is the one you created when you are creating your virtual machine. And here the content of the file. Now, every comment that I want to type it now, it will be executed as the general user. Now, if I want to do sudo-i, then cat test1.txt or whatever. Okay, sorry. Sudo-i, let's say ls-l. So here it is showing the list of directories or files. You have only directories that is part or the root or the super user has the privilege to execute it. Now, if we go, we are now as a user. Okay, let's do -i, and that's it. Now you can see that we are the root. Now, instead of Amal as the username, now the username is root. And here, whenever we are creating or executing a new command, we are executing it as root, as the super user. Now, let's see how to divide the permission. Sorry. So a user can own files and directories, usually by creating them in the first place. Means that user has control over its access. Here, the user can belong to itself. As we said, it can be the user, for example, Amal, or it can belong to a group. And for a group, you can define files and directories to have group permissions. For example, when you are working in an industry, you have a group that they are working on the test, let's say. So this group of people only have permission to execute these files into this directory. They cannot write, so they can only read and execute. For example, I can create a group for this class where everyone I add to the 1310 group can access specific folders and directories. And here, the owner will give us access to everyone in the group. Now, the owner of a file or directory can grant some set of access right to everybody else. Now, let's see how the directories or how the permissions are divided or how to decode the file permission. Now we have multiple types for, like we have the file, we have the directory. So for the files, we can see a dash. So if we have a dash, means we are reading the permission of a file. If we have a D, this means that it's directories. If it is length, so it's for links. If it is C, means it's for characters, etc. But in this course, we will be only focusing about files, means the dash, and D, which is for directories. The other types we will not be focusing on. So here will be already, where is it? So here we already seen the output of lsn-l command for certain files and directories. So here, let's start by decoding the first line, which is dash rw dash rw dash r dash dash one amal amal, etc. So the first character refers to the object type. Like we said, it can be a file, a directory, a link, or whatever, but we'll be only focusing on the file and on the directory. Now, the next three characters refers to the permission for the file owner or the user. A user, as we said, can own a file or directory. This is what the first three characters means amal, the first amal, or the first reach. In the second example here, R, or this user amal, has the right to read and write and not execute this file, this given file. And for reach, for example, this user, Rich, has the permission to read, write, and execute this program, my program. Now, this is the first three, or the first four, the second, third, and fourth character. Now, the second group, or the next three characters, refers to permissions for the group, which is the second column here. Now, the group is by default, the group is usually your name. Means here, if the username is Amal, means the group will be automatically Amal. You can rename it later or working, but this is by default. If the username is Rich, so the group name will be also Rich. Now, the last three characters refers for permission for anybody else. Means these are the permissions for anybody who is not the file owner and does not belong to this group. And we usually represent these three last characters as others. Means they are not users and they are not group members. Now, the number one means or indicates that there is one hard link to the file. If you were to create additional hard links to the same file, here, of course, the number will be increased. Then we mentioned that the first name is the user, the second name is the group name. Then we have a number which is the file size or the directory size or whatever. So here we have the file size. This test1.txt has the size 1710. Now, the one after is the date of the last modified. So when it was the last time we modified this file test1.txt. So here the most important or the parts of the file permission. We have to the type object, then the permission for the owner, the file owner, the group member, and for the others, then how many hard link we have, then the username, the group name, the size of the file, and the date, and of course, the latest thing is we need to specify the file or the directory we are working with it. Now, as we said, dash is for file, D for directory, So we generally see some sort of template like above. So the first character indicates, as we said, the type of the resource or of the object. The RWX refers to read, write, and execute permissions. If you have a dash character, means that permission is denied. For example, for the first one, we have D means directory, read, write, execute for the user, then read. So the group here has the permission to read and to execute, but not to write. So when we have a dash here in the middle of the permissions, means this permission is denied. So the read permission, the user can open the file. The write permission, the user can make changes to the file. And the execute permission is when the user can execute the file. And we already did this when we opened the test1.txt. We are already executing this file. Now, again, we have 4 possibilities. R to read the file permission, W to write for the write permission, X for executable permission, and dash is used to indicate that permission is denied. Now, each of the 3 sets refers to different levels of permission. The first one is for the owner of the object. The second part is for the group that owns the project. And the third part is the permission for everyone else on the system or just others. Now, if we type ls -n, we see dash rwx, r-x, r-x, 11, etc. So the first one is refers here to the file since it is dash. Then amal indicates that this is the owner, and the second amal indicates the group name of the owner. Then the 3 rwx means that the owner of the file has the read, write, and execute permission for a.out. The second part is that, which is r-x, indicates that the group of the owner can read and execute this file but not write to it. And the third part, or the third set of characters, means that, which is r-x, indicates that everyone else can read and execute this file but not write to it. Okay, so here we have more explanation. What does R means for a file? So if we have R and we are interpreting a file, means that the user or the group or others allows a file to be opened and read. Now, if it is a directory and we have R, means allows the directory's content to be listed if the execute attribute is also set. So here we need also the X and not the dash instead of X, besides the R, of course. Now, if we have W for a file, means it allows the file to be written to or truncated. However, this attribute does not allow files to be renamed or deleted. The ability to delete or rename files is determined by directory attributes. Means here if you have the permission to write, means you only have the permission to modify the content of the file and not the structure of the file. The structure means the name, or you want to remove it or delete it, or you just can modify the content of this file right inside this file. Now for the directory, this allows files within a directory to be created, deleted, and renamed. Here again, we need the X besides W. This way we can create or delete or rename files inside a directory. Now the X for a file, it will allow the file to be treated as a program and executed. Like for example, we were printing the content of test1.txt. So program files here written in scripting languages must also be set as readable to be executed. Now if we have X for directory, means it allows the directory to be entered, for example, CD directory, means we have access to it to be inside of this directory. Now, here we have more permissions example. First one, when we have a file, because we have a dash, then the user has the ability to read, write, and execute, and no one else has any access. The second example, we are always looking for a file, and which is a regular file that is readable and writable by the file's owner, but no one else has any access, and the file owner doesn't have the access or the permission to execute this file. He can just read it and write on it. Now, the third command, which is or permission, which is a regular file, because again we have a dash, which is readable and writable by the file's owner. Members of the file owner group may read the file, because as you can see, for the group we have only R, and also others have only the permission to read the file. Now the fourth example, which is dash RWX R dash X R dash X, means it's a regular live file which is readable, writable, and executable by the file's owner, and the group and others can only read and execute this file. Now, if we go to the before last one, which is this one, D, means we are working with a directory. Here, the owner and the members of the owner group may enter the directory. Why? Because they have the possibility to read, to write, and execute, means they can enter the directory to read it, they can create, rename, and remove files, because they have the permission to write and execute. The last example is we are working with a directory. So a directory here, the owner may enter the directory and create, rename, and delete files within the directory. Why? Because here we have the permission to read, write, and execute for the owner. Now for the group, he can enter the directory, but he cannot create or delete or rename files. Why? Because we don't have the access to write as a group. And of course, others, they don't have the access neither to read, to write, or to execute the directory. So these are some examples, permission examples. Now, by now we know how to or why we use permission, how to read a permission to know what is the permission given for this user, what is the permission given for this group, and what is the permission given for others. Now, if you want to change the permission of someone or some group, how can we do it? Sorry. So to do this, we need the command chmod. So only the super user of the file's owner can change permissions. You, as a normal user, you cannot change the permission of your friend. Why? Because let's say we are in a company and you are in project 1 group and there is another project 2 group. So as a user, as a simple user, you cannot change the permission of your sibling. Means you cannot, for example, change the permission of someone else from project 2 group. You need to be the super user or the file's owner. Now, if you want to change the permission, we need chmod, like we said, and only the super user of the file's owner can change the permission. So how to change? Okay, now let's say we are the super user. Let's say how to change the permission. Actually, there are two different ways that you can change these permissions. The easier way is with symbolic notation. With this notation, I specify which category, user, group, or others that I want to change. Then I do plus or minus or equal the permission. the permission I want to give it to the user. Now, if I do add, or if I want to add, I just type plus. If I want to remove a permission, I just type minus, and I type the permission. And if you want to set, I just make or type equal, and of course the permission. For example, so as we said here, 3 things we need to specify. To who should I give? If you want to give it to the user, to the group, or to the others. Or A, to see that combination of the U, G, and O for everybody. Now, which permission do you want to give or take away or to set? To add, let's, as we said, plus, to take away, minus, and to set is equal. Now, what are these permissions that you want to give it to this person or to this group? Which are, it can be R, W, or X. So let's say we we give the permission for the user. Let's say if you want to give the permission to the user to execute the test1.txt. So how can we do it? So let's say here, come on. So I just opened new terminal because the previous one was stuck. So we can go, for example, to cd downloads, and here we have downloads, we have the test1.txt. Now, let's see before what are the permissions given to this file. So here we are going through a file. So the user, which is Amal here, has the right to read, to write, but not to execute, has the right to read, write as a group, and only read as others. Now you wanna give chmod u means user, plus x means we wanna give the permission to execute to the user, and we specify test1.txt. Now cls minus l. So here we have the permission added. Again, if for example we want to give chmod other, or let's a plus x to test1.txt. So if we type, we can see that the user, the group, and the others has the permission to execute this file. So this is how to change the permission to a user or all, or we can type, for example, here chmod group, or let's remove the permission of to the others, remove it. You want to remove the permission to execute test1.txt. And now if we type ls-l, we can see that the others don't have the permission to execute this file anymore. So this is again how to change the permission. Now, as we said, the symbolic notation. We have the U to which is the short for user, but means the file or directory owner. The G to say it's a group owner, O for others, that means world, so everybody else, and A, which is short for all, which is the combination of the user, the group, and the others. Now, let's see some notation examples. If we have U plus X, means you want to add execute permission to the owner. You want to give the permission of the execution to the user. If we have U minus X, means we want to remove the execute permission from the owner. Now, if we want to just have plus X, means it will add the execute permission for the owner group and word, which is equivalent to A plus X, which is give the permission of the execute to everybody. Now O, as we said, means others. Here we are removing the permission of reading and writing to the others. Now if we wanna GO equal RW, means we are setting the group owner and anyone besides the owner to have read and write permission. If either the group owner or word previously had execute permission, they are removed. So the opposite. Now, if you wanna U plus X, comma, G, O, receive or equal Rx, means we are going to execute the permission for the owner, which is the user, and set the permissions for the group and others to read and execute, which is Rx. So multiple specifications here can be separated by comma. You can, if you want to have, or if you want to give a separate permission to the user and different other permissions to the groups and different other permissions to others, you can just specify or separate these permissions between comma. U plus or minus or equal, whatever you want to give, G, and plus or minus or equal, whatever you want to give, and others the same. So let's say we have chmod U plus X. U, as we said, it's user. X plus means we are giving a permission to this user. The permission here is the executable permission, or the permission to execute the test.csh. Now, if you want to chmod A receive or equal rw test.sh, means gives the user, group, and everyone else read and write permissions. This is for now. Now, if anyone had already the executable permissions, those are now removed. Means if by default, let's say user has the executable permission, it will be removed because we are only setting the permission of reading and writing to the user, the group, and to others. Now for chmod G dash or minus X, so here we are removing the executable permission from the user. Let's try the chmod, say A equal X. So before we have the RWX for the user, RWX for the group, and R for the others. Now, what we are doing is we are changing the permission to give all the user, the group, and the others the permission of reading and executing. Now, the user and the group, the permission of writing for the user and for the group should be removed. Oh, we are missing the name of the. Okay, now, as you can see here, the W is removed from the user group and from the group permission. So this is how to change, this is one way on how to change the permission for a user. Now we will see the second way. which is to use the octal notations. So we just saw what we have as permissions here with dashes x, y, and x. Now, we need to see how or the other way to represent things. Okay, first or before that, we need to know how to convert from binary to octal, or what is or how it is done, the octal and binary conversion. So you will find this file as well with the recording and with the slides. So the binary number, which is a binary number expressed in the base 2 numeral system or binary numeral system. This system uses only two samples, which are the 0 and the 1. So to summarize, a binary number, it is only contain 0 or 1, zeros or ones. Now the octal number, which is a system, is the base 8 number system, and it uses the digits between 0 and 7. So let's say here from a binary how to convert to octal. So we will start from the right because the least significant number is all the way to the right. So 2 exponent 0, it is 1. 2 exponent 1, it is giving 2, and 2 exponent 2, it is giving 4. So this is something that we need to know before starting. Now we mentioned that the binary number is containing 0 and zeros and ones. So let's see here we have 0, 0, 0. How we gonna convert this binary number to an octal number? So to do this, we need these ones. 2 exponent 0, 2 exponent 1 for the second 0, and 2 exponent 2 for the third 0. Now, the 2 exponent 0 will give it multiplied by 0 is giving 0. The 2 exponent 1, which is giving 2, but if it is multiplied by 0, so it is giving 0. And 2 exponent 2, which is giving 4, but since it is multiplied by 0, so it will give 0. That's why here when we are doing the sum of 0 plus 0 plus 0, so it will give 0. So this binary number, it will give in octal 0. Now, let's try the 0, 0, 1 in a binary, as a binary number. Now, again, we'll be using the 2 exponent 0, the 2 exponent 1, and the 2 exponent 2. Now, the 2 exponent 0 is giving 1, and here it is multiplied by 1, so it will give 1. Now, the 2 exponent 1, it is giving 2, and it is multiplied by 0, so it is giving 0. Same for 2 exponent 2, it is giving 4, but it is multiplied by 0, so it will be giving 0. So here 0 plus 0 plus 1, it will be giving 1, which is the octal number. So 001 in binary, it will give us 1 in octal. Now, for if we have 0, 1, 0, same thing. We always need to put 2 exponent 0, 2 exponent 1, 2 exponent 2, and every time we multiply this 2 exponent 0 by 0, 2 exponent 1 by 1, and 2 exponent 2 by 0. And here we got 0 because we are multiplying by 0, 2 exponent 1, which is 2, here multiplied by 1, so it is 2, and 2 exponent 0, which is giving 1 multiplied by 0, it will give 0. So here we have 0 plus 2 plus 0, and it will be 2. Let me just make it bigger. Oops, I missed it. Okay. Because I was trying to put the 2 exponent 0 just with the same column of 1, 2 exponent 1, it will give 2, and it is multiplied by 1, so we have here 2. Here we have 1 multiplied by 1, so it will give 1, and here 4 multiplied by 0, so it will give 0. So here 2 plus 1 will give 3. So 0, 1, 1 in binary will give 3 in octal. Now we'll try with 1, 0, 1. So here 2 exponent 0 will give 1 multiplied by 1. So here we have 1. 2 exponent 1 multiplied by 0, so it is 0. 2 exponent 2, which is giving 4 multiplied by 1, will give 4. So here we have 4 plus 0 plus 1, which is giving 5. Same here, for example, for 1, 1, 1. So we have 2 exponent 0 multiplied by 1. So it is 1. 2 exponent 1 multiplied by 1. So it will give 2, sorry. Here 2 and 2 exponent 2, which is given 4 multiplied by 1, it is 4. So here 4 plus 2 plus 1, it is given 7. So the 1, 1, 1 in a binary, it is given 7 in octal. And this is how we got the 7, which is 2 exponent 2 plus 2 exponent 1 multiplied by 1 and 2 exponent 0 multiplied by 1. So it is 4 plus 2 plus 1, which is given 7. Now, for the octal, if we have 0, means we don't have a permission for anything. Now, if we have 1, means we have the permission to execute. If we have W, means we have the permission of writing. So here is the permission, the 1. Now, if we have 0, 1, 1, which is 3 in octal, means we have the permission of writing and executing. If we have 4 in octal, means this user has the permission to only read. If we have the permission 5, means, we have the permission to read and execute. If we have 6, means this user or this group has the permission to read and write and not execute. And if we have 7, means this user or this group or other has the permission to read, write, and execute. Let's see an example. So we have chmod 777, and here we specify the name of the file. 7, the first 7 is for the user, the second 7 is for the group, and the third 7 is for others. Means all these user group and others have the permission to do anything, to read, to write, and to execute. Now, the second example, 6. So the user has the permission to read and write, which is here, to read and write. 4 means the group has the permission to only read because it's only 4 for the group, which is here, and 0 means the others don't have the permission to read or to write or to execute. They don't have any permission as others. Now let's see the third example. When we have chmod 775 and we specify the name of the file. Here means the user have all the permissions to read, write, and execute. Same for the group. They have all the permission to read, write, and execute. And 5 means that the others has the right to read and execute, but not to write. So this is the second way how we can change the permission of user of a group or of others, which is here we just explain it. So if it is 0 in binary, means it is 0 on octal, means it is no permission. So if it is 001 in binary, it is execute only permission. If it is 2, means it's write and execute, write only permission. If it is 3, means it's write and execute permission. If it is 4, means it is read only, etc. So the octal notation. Or before that, let us go and change the permission. So we were using the symbolic notation to change the permission between, for example, the user, the group, and others. Now we are going to use numbers to change this permission, which is the binary octal notation. Okay, my again. My mouse is running and I cannot see it. Let's make or let us again check the latest permission for here. Okay, let us do cd download. Let's share. Okay, so we have the permission of reading and executing for the user, same for the group, and same for the others. Now let's change this to 777 means we are giving the permission to read, execute, and write to the user, to the group, and to others. Test1.txt. Now, if we type ls, you will see that everybody has the right to read, write, and execute. So these are the two ways to change the permission to the users or the groups or the others. Now, again, this is what we just did. So chmod 777, and we specify the 5. So here we have made this homework script executable for the user, the group, and for everyone else. Now for chmod 640 means we are giving the 6, which is for the user, means we are giving the readable and writable permission for the user only. Now for the group, they only have the read execution and there is no permissions for others. This is the main, or this is how to give the permission or to change the permission to the user, to the group, or to others. Now, what is the main difference between the octal and the symbolic representation? The main difference is that the octal notation sets permissions for all 3 clusters simultaneously. Symbolic allows you to set a single attribute without disturbing any other. And the symbolic is also generally easy to remember because every time for the octal notation, it will need, okay, 6 means read and write or whatever. So every time you need to remember what is this number for. It is for read or write only or read, execute or whatever. But both works. Now, let's move to the second part, which is how to create file and directory archives using tab. Then we see how to display the contents of an archive file, then how to extract archives file, and how to create compressed archive files using the gzip, and how to uncompress these files using the g and zip. Then we see the combine tar and gzip comments, and then we'll be displaying the file size using du, and we identify the type of file using the file comment. Now, let's start with the tar. So the tar comment in Linux is one of the most essential commands when it comes to a file manager. So it is short for tape archives, and it is used to create and extract archive files. An archive file is compressed file that contains one or more files bundled together for more accessible storage and portability. So at least you may probably face the situation when you need to compress your or to archive your files. Now, what are the main components of this command? We have the tar, which is the name of the command. Then we have the operation mode, we have the option, and the name of the archive file, and then the file or the directory to be archived. Now, the operation mode, which indicates which operation executes on the file. Because this command can do multiple things, can create, can extract, can do multiple things as for archives. So here we need to specify which type of operation it is going to do. It is going to create, or it is going to extract, or what else. So this command allows and requires only one operation, which makes sense because you cannot create and extract at the same time. So here we need to specify which operation you are going to use. If you are using -c, means you are going to create an archive file. V means you are printing verbose information for any tar operation on the terminal. T to say that this lists all the files inside an archive file. U to say that this archives a file and then adds it to an existing archive file. R me to say that this updates a file or directory located inside .tar file, and F to specify the file name of the archive file. So let's this function also can compress and uncompress an archive file. So here, as we mentioned earlier, we have the C to create a file, the F to specify the file name, the V to print the verbose, etc. Now, let's try this command. So to extract a tar or to extract an archive, we need to specify tar-x stands for extract, which is used to extract files from an archive. Z to say that indicates that the archive is compressed with the gzip, and it then starts to filter the archive through the gzip before extracting it. Now, the V, as we said here, to say is a verbose, so to give you information about this operation, and F, of course, to specify the file name. Then, if we want to create a compressed gzip archive, so we need the command, the operation here, we are creating, so we need to specify the C, Z here, as we said, to indicate the archive is compressed with gzip, and V to say the verbose information, and F to specify the file name. So here we need the command name, this operation, the options, and your archive.tar.gz, and then your directory or file. Now to do the uncompress of gz file, we need we will be using the command gunzip and the file .gz. So let's try these comments. So let's start creating tar or using tar. Then, so here we have a directory named Flint. Okay, so what we are gonna do is try tar flint and see. So tar on option F requires an argument, try tar, etc. So here, this command requires operation mode. That's why we need here to add the operation mode to see if we are creating, if we are extracting, or whatever. Now C to say that we are creating, V to give the verbose information about this option, and F here to specify the file name. So CVF, then what we want to be the output after the archive, then what is the file that we want to archive. So tar, the comment, C to say we are creating an archive file, V to give the verbose information, F to say that we have a file, and flint.tar, the file that we want to find it here, flint.tar, and we want to archive this folder. So after doing this, we have flint.csc. Why it is doing this? Because if you go here, so as you can see here, we have flint.tar, and inside it is this directory. We have already another directory named CSC. Means here we are arguing the files. Where is it? We are arguing the flint file, the flint directory, and the CSC directory, which is inside of the flint directory. This is inside the flint.tar. So we are arguing the flint directory and what is inside this directory. Now, this is if you want to create. So what we did is we create a tar directory. Now, if you want to create a compressed JZip archive, so we need to add, we go again here, say CG or no, to say it's zip file, so we need to add the zip. So CVF, then we print that is tar.gc, and then what we wanna directory or file that we wanna archive is this flint directory. Now, if we type this, we're gonna find here another compressed archive directory. So if you want an archive directory, we just need to put G, C to say we are creating a new file, V for the verbose information, and F to specify the file. And if you want to zip this file, we just need to add the C to say we are going to compress this file to JZip file, and we need to give the name of the new folder that we want to get it after zipping this file. And again, it is making the compression for the flint and the folder inside of it. Now, if we want to uncompress this file, we just need J and zip, and the name of our file. So J So we just need the J and zip, and we specify, for example, J and zip and flint.tar.gzip. So this is to create an archive. Now to combine tar and gzip commands at the same time, what we need to do. So we can use, or we can combine a tar and gzip commands using the pipe. to create a compressed archive without storing an intermediate tar file. Now, if you want to display the file size using the du, so we just type the du command, and we have here two options. The S, which to summarize, and this option displays only the total size of the specific file directory, and the H means it's human readable. This option prints the sizes in human readable format, such as kilobytes, megabytes, gigabytes, etc. This is how to, or this is to check or to display the file size of your directory or of your file. Now, if you want to identify the type of the file, so someone can ask, why do we need to identify the type of the file? For example, if you are working in a company and you are only looking for the .txt files, so you don't need to look or search into some files that they are not .txt and you're only concerned about the .txt files. So it will save you time when you are searching, for example, or when a user have access or should have only access to the Python or the Java folders, so or the Java files. So you are only here giving him or to know that you need to know the type of this file to know if you should give this permission to this user to open this file or not. So before that, you need to know what is the type of your file. This is just some simple examples of the utility of knowing the type of the file. Because someone says, okay, why do I need to know the type of file? These are some examples. So what we have now, right now, we have the flint.tar, the flint.tar.gz. Now, what we can do is tar dot dash c means to create, verbal information, f to specify the file. Now we used to put flint dot tar, the name of the file the new name of the file that you wanna archive it, and the flint, which is means we want to archive the flint file into a new file named flint.tar. Now, what if you wanna put some files into this file? Like for example, or means copy and not remove. So test1.txt, test2.txt, which they are. So we have test1 and test2.txt. We wanna put these two files into the flint.tar. So right now it is at all. We were working with flint. So right now we have only flint and which has inside the CSC. Now let's see what we will have if we type this. So inside the flint.tar, we will have the test1.txt, test2.txt, the flint, and inside this flint directory, we have another folder, which is, so we will have the flint, the test1, and test2. Remember, or be careful that we are just copying these two files into the flint.tar. We are not removing, or we are not removed these files from here. We are just making a copy in the flint.tar. Now, if you want to see tar.tvf flint.tar, here it will give us the permissions, the files, so test1 with the permission, test2 with the permission, flint, and the CSC folder. Now, we want to do this one. So we're gonna combine the tar and the gzip command. So what we can do here, tar, then CSC-CVF, then the name of the files that you wanna put, or let's say mal dot test one dot txt, and here the pipe gzip. So this is for the first part. Then we wanna combine or we wanna compress this archive without storing an intermediate tar file. So what we wanna type this into dot. Now, if you wanna see, you can type command dot tar dot g. So if we go here, we can find ml.tar.gz, and if we open it, okay, it's locked. We should find the test1.txt file. Why? Because we are combining two commands, the tar and the gzip, and here using the pipe and using this greater than sign when to create a compressed archive file named mail.tar.gz, and also we were copying the test1.txt into this tar or archive file. Now we want to see the size of, for example, let's say test1.txt. So what we should do here is tu slash s for size, h for human readable. Then we specify the name of our file. And here it is 4 kilobytes. Now if you put just s, it will give us 4. But if you don't know, okay, now we just knew that it is 4 kilobytes. Now you don't know here if it is a big size, if it is 4 kilobytes or 4 megabytes or gigabytes or whatever. That's why here we need to specify the unit of it is kilobyte, gigabyte, or whatever. Now let's move to the next part, which is to install a tree. Or let's see what is the tree program and how to install it using the command apt, how to copy a directory recursively using cp-r, how to remove files using rm, how to remove files using the pattern matching with wildcards, star and question mark, and how to remove directories recursively using rm-ri. Let's start by knowing what is a tree. So tree is a command line utility that displays the hierarchical structure of directories and files in a tree like this form. So we have the root, we have directory 1 inside it we have file 1 and file 2, and in directory 2 we have subdirectory 1, and inside this subdirectory 1 we have file 3, etc. So If we type sudo apt update, it will update the package list to make sure that you have the latest information about the available packages. It is just like you are refreshing the content of your directories. Now, if you put in sudo apt install tree, means you are installing the tree program. Here, make sure you have administrative privileges to install this package. And here another power for the root or for the super user. You can then use it to display directory structures in like tree, like format by running the tree command in the terminal. So let's start installing and updating these files, then we can finish. So let's try sudo apt update and see what it will say. So here it will ask us to enter the password, and here it is working on the updates. So here it will show us the percentage of reading, 7% of progressing. Okay, now after checking if you wanna install this tree program, what we need here is to apt install tree. So if we go back here, let's make sudo apt tree, or sorry, apt install So it is installing and it is working on the installation. Now, as you can see, we are running, or we are executing this command as an administrative, as a super user. Why? Because we are using the sudo. So this is what we have. The following new packages will be installed: 3, 1 newly installed, 0 to remove, etc. After this operation, 16 kilobytes of additional disk space will be used, etc. So it will give you more details about what is happening when you are installing the tree. So here we have, we are gonna copy what we have directory and what it have inside. Like for example, if we go to Flint, we'll find the CSC inside of this folder. So we are gonna copy the content of, we are going to copy Flint and what we have inside the Flint and put it in the folder. So what we need here, copy recursively Flint, and we are gonna put it in amal directory. Now, if we go here, we check the amal, we have Flint and what is inside. So because we were putting R, so the Flint and what is inside this Flint folder. Now, if you wanna, let's try to copy recursively, or let's do it with command, and here we wanna create new folder named backup. Oh, omitting the tasks. So since we have something in this directory, means we need to know if we are going to add recursively, which should be the case here because we have something in this directory. That's why here we need to ask R. So now if we go, we can see that we have a new folder created named backup, and inside this backup we can find what is inside Amal. So we don't here, as you notice, we don't have the name of folder Amal inside, but we have only the content of the back of the Amal folder inside will be inside of the backup folder. So this is to copy a directory recursively. Now, if you want to remove files or directories, let's say here we have test1, test2, test3, and test4.txt. Now, we can just remove and we specify the files, or we can say remove star.txt. Star here means that we want to remove every file that has the extension .txt. Now for the third one is when remove file with a question mark means we want to remove a file that starts with the name or the word file, F-I-L-E, then one character after, then .txt. Means this wildcard will match any single character. So file1.txt, file2.txt will be matched and removed by the remove command. Now let's try to rename or to add another file. Okay, let's create a copy and then name it file. File1.txt. Okay, now if we go here, we type remove. So we are gonna let's try this one, remove. We specify file.txt, and here only one file will be removed. .txt. Now the only file that will be removed is file1, because this is the only one that matches with this pattern. Now if we go to the terminal and we see, let's maybe here it's more visible. So you can see that it's gone. Now, if you want to remove all the files that they have the extension .txt, you can go to the terminal, go to remove, and wildcard here is .txt, and it will be removed. So we will not find any file here with the extension .txt. But here, be careful when we are using this command, especially with wildcards, because it is permanently deleted and the operation cannot be undone. So you cannot go back. If you are losing or if you are deleting your files, means you are deleting these files forever. So you need to double check the files you are removing to avoid any accidental data loss. So the last thing here is when we want to remove directories and their contents recursively. We have rm which stands for remove, -r to make recursively, and a to say that is enable interactive mode, prompting you confirmation before removing each file or directory, which is something good. So it is better always to use this interactive to kind of double check every time if you want to really delete these contents or not. So for example, we have your Flint, we have CS, etc. So if you want to remove this, you can just put rm/recursively interactive remove the Flint. So here rmdesign into directory Flint, remove directory Flint CS, yes, remove directory Flint, yes. And if we go and check it, we will not find it here. So the good thing here with the interactives that it is asking in details which folder and the directories and the subdirectories inside this folder, and make sure that you want to really remove it, because as we said, you cannot go back again and restore and get these files again. So this was the lecture for today. Hope you enjoyed and you learned something new. See you in coming lectures.